All right, Mercedes, help us get started with the bell work today. This first one here, finding the intersection point for the system of equations, is something we did first semester a long time ago. Do you remember what we're supposed to try?
Well, you said matrix.
We could try a matrix, yeah, or an augmented matrix. So for number one here, how big is this matrix going to be?
That's 23. 5, 2, 3.
Okay, you can do a 3 by 3. That'd be fine. Or you can do a 3 by 4, where it's like an augmented matrix, right? But if we tried a matrix representation of this system, what would be my first 3 elements then?
1,
Yeah.
-3,
Eh.
+3.
Eh.
What?
There's a space right here, intentionally 1, 0, -3. We have 1 x, 0 y's, -3 z's. What's the second row going to be?
2,
Yeah.
-1,
Yeah.
2,
Yeah. Third.
7,
Yeah.
3, -5.
Okay, so that is a matrix representation of the left side of these equations. Do you remember what I do to that?
What?
Do you remember what I'm supposed to do to that?
You multiply it by you start with the -5, 16, 19.
There's one thing you're missing. It's not really this that we multiply it by, but we multiply by its inverse. All right, so if you grab your calculator to do this, then we're going into the matrix part of the calculator. We need to make a 3 by 3 and a 3 by 1 matrix. Second, okay, yeah. 2, 7, -3, -5. And then you have to go back in and make in matrix 2, make that a 3 by 1. And it should be -5, 16, 19. And then how you want this to be typed out is pull up matrix A. Oop. Inverse button times matrix B.
Wait, I have.
And then if you haven't typed it like this, you should get, if you hit enter, this. Which means x is 4, y is -2, and z is 3. Okay, let me refresh you. You learn how to do that?
No.
I don't think you ever did that.
No, never in my life.
Okay,
So I do here in no matrix, right?
that's right. And then we're going to edit these. So you go to the edit tab,
Oh.
hit enter on the first one. Oop.
Oh, do I do enter now?
Uh-huh. And you're going to make that as a 3 by 3. So 3, enter, or yeah, right, 3, enter.
Oh, this is 3. Okay.
That's right. And then you can then type into each of those cells what each of those are.
Like this.
Did you find that placement, Sonia? Yeah, there you go. Do you all remember how to do that?
Yeah.
Got it? Jada, Mercedes, Jake, you 4? Up here? What's up?
Oh, I'm just going.
Oh, it finally turned, it was staring at the board for a while. It lost me for a bit. Okay, yeah. That looks good. All right, and then to get out of it, you hit second mode. And then we have to go back into our matrix menu. And we got to edit this second one. So we go to edit, just go to the second one, we need to make that a 3 by 1. So 3, 1, and then negative 5, 16, 19.
It followed him all the way back here.
And then enter. And then, yeah, quit again. Okay, now to start doing math with them, you can hit second matrix, enter, we'll grab number 1. So if you just hit enter right now. And then inverse times, go back to the menu, grab the second
And
one.
this dude walked in.
Enter.
I hear his phone
Yay.
on the floor. And it did not sound
That saves
good.
you a lot of time on the
It did
ACT
not sound good.
instead of
And he goes,
substitution, elimination, or all those.
dude.
Okay.
Looking at his phone, I could see him standing there. I just broke my phone, and he walked out. This dude really walked in the bathroom to break his phone.
All right, Jenna, let's go back to number 2. We need to solve for theta, where theta is between 0 and 360 degrees, for this equation. Sine squared minus sine of theta is equal to cosine squared theta.
I was just sitting there.
Okay, I'm going to mute this. So, Jenna, based on our notes from yesterday, this looks like quadratic form on the left, right? We have a quantity squared minus just a quantity, right? Where if like we replace sine of theta with x, that would look really good. Except for that, that's an issue. That's not in terms of sign like the rest of these are. So that x substitution won't really work. But is there a better way we could write cosine of squared theta? What is the cosine squared theta? You could, but we should think there's a squared. There's a trig function squared. So we need to get rid of that. There are some identities that use trig function squareds. Check in my notes. There are 3 of them. Yeah. No. Those ones don't, those are identities. But those aren't the ones with the squared. The ones with the squareds in them are the Pythagorean identities. Right? There are 3 Pythagorean identities. Sine squared of an angle plus the cosine squared of an angle is going to be equal to 1. The 1 plus the tangent squared is equal to secant squared. And 1 plus cotangent squared is cosecant squared. All right, do we have those in our notes? Found them? Whenever you see a squared in your problems, you should think, is there a way I could use these to make this problem easier on myself? And there is, right? For our problem, this identity, I could subtract sine, and this is the same thing as cosine squared theta is 1 minus sine squared. Right? So instead of writing cosine here, I could write that the sine squared of theta minus the sine of theta is equal to 1 minus the sine squared theta. And now all of this is in terms of a single trig function, and we could do that x substitution, where we say like x is the sine of theta, and then this just becomes a regular old quadratic. If it's a quadratic, what do we need it to equal on the right? And we need it to equal 0. So what's the first thing you should do? Sure. Well, how do I get rid of the 1? There you go. So then it'll be sine squared, 2 sine squared theta minus the sine of theta minus 1 equals 0. All right, you want to factor this or quadratic formula?
Wait.
Oh, you get to pick. It's either both work. Okay, factor it. So this one, your a value is not 1, so you do need to pay closer attention to what you're doing here. But I'm going to tell you, with numbers this small, I might just guess and check to factor it, rather than going through the full-blown AC method. Yeah, it would have to be 2 and 1. That's the only thing that can multiply to be 2. So these two together now will be 2 sine squared. So now, and this also only has 2 options, right? If it's factors, positive 1 and negative 1. So I don't know. Let's just guess, and if that doesn't work, we'll switch them. Do you want the positive 1 here in the left factor or the right factor? You get to pick. It doesn't matter, because if it's wrong, we'll just flip it. Yeah, let's try the left one. If it's wrong, we'll flip it. Okay, so let's check our answer here. 2 sine of theta times sine of theta is 2 sine squared. Yay! 2 sine of theta times negative 1 is negative 2 sines of theta plus 1 sine of theta would give us a negative 1 sine of theta. Yay! And 1 times negative 1 is negative 1. And again, if that didn't work out, all that would happen is this would be positive instead. You'd flip it. Or if it turns out that you try all the options and none of them work, then you can't factor it, right? And you go and do the quadratic formula. All right, so thank you for starting that, Jenna. Rowan, I'm going to have you finish it. I have 2 factors. Multiply together to equal 0, which means these has to be 0. So let's solve them separately. 2 sine of theta plus 1 equals 0. What's the first thing you would do? 2 sine of theta equals negative 1. What's the next thing you would do? Sine of theta equals negative 1/2. What's the next thing you would do? Yeah! And actually, that should have an exact answer. I mean, you could use your calculator. It'll tell you what the exact answer is, since we're doing it in decimals anyway. But I didn't leave myself enough room.
It's in degrees.
It's in degrees, yeah. Yeah, did I say decimals? Yeah, it's in degrees. So that'll give you an exact answer anyway. What'd you get? Negative 30. Okay, that's wrong. Right? Because it has to be 0 to 360, right? Negative numbers aren't included as solutions according to our prompt. So what would I have to do to this? Add 360. That'll give us the coterminal angle that is in the range. So the answer is 330 degrees. Is this done? Is that the only answer? No! Okay, that's the answer in quadrant 4, right? In what other quadrant is sine negative? Yeah. How do I find the angle in quadrant 3?
Oh, because I see
But yeah, I mean, you could read, again, for this one, you could, if you have your unit circle memorized, right, it is one of the values on a unit circle. But if it wasn't, or in general, if you want to find an angle in quadrant 3, it's 180 degrees plus the reference angle, right? I mean, just draw a little picture and think about it. If I want to find my angle, if this is my reference angle, right, and I want to find that same angle in quadrant 3, I go 180 degrees plus the little reference angle. Okay, so then this will be 180 plus 30 in our case, so 210 degrees. Okay, and that was for that one. Now we got to do this one, sine of theta minus 1. Well, that one's a little bit quicker. To help me work through that one, Kate. sine of theta minus 1 equals 0. What do you do? Sine of theta equals 1. What do you do? Yeah. Theta will be the arc sine of 1 at what angle is that? 90 degrees. Right? Think about your unit circle. When is our y value 1? It's 1 when it's at the top of the unit circle, 90 degrees. And that's the only spot between 0 to 360 where that happens. So here's your 3 answers. Okay, so as you get ready to do the homework on this, and then when you start working on the review Monday and Tuesday, to get ready for our test on Thursday, you might be uncomfortable or you might not feel confident about these ones, because it's probably the hardest thing, I think, in the chapter, besides maybe the proofs or the simplifying of trig identities. Sometimes that is difficult. So at the end of the problem, you can always go to Desmos or use your TI-84, graph both of them, and check the solution. Yeah?
I am confused, like, how, like, when we have two answers with this one. Like, in that case, we have one.
This will basically only happen at 1 and -1. Because at the max and min, if you think of your sine curve, right, going up and down, right? Oh, here, I'll just draw it. What am I doing? Mr. Lake, what are you doing? What are you doing here? Let's draw it. All right, this is your sine curve, right? Okay. Only at 1 and -1 will you have one answer. Everywhere else, if you draw a line, it'll happen. Every other y value will happen at 2 parts between 0 to 360 degrees. Right? The only time that the line crosses it only once is at this minimum point and the maximum point.
Yeah, but like for the first one, how do we know that we have two answers and not just one? Like 330 and 100.
Oh, for this first one? Because at a half, right, that'd be like right here. I mean, you could say, the other issue is when I say this happens, right, like if you remember the prompts, I say, all right, in what other quadrant is sine negative, right? This one is in the 4th quadrant, which is the other quadrant, right? You can't do that analysis with you. Because if I say, all right, which other quadrant is sine positive? This is in the, well, what quadrant is this point in? It's not in quadrant 1, and it's not in quadrant 2, right? It's a quadrantal angle. It's between quadrants 1 and 2. So when you try to do your analysis and you say, all right, in which quadrant is 90 degrees, you'll write, oh, it's on the y-axis. It's not in a quadrant. So that'll be another strong hint to you that that's the only solution. The last strong hint for you that that will be the only solution is you'll grab your TI-84, you'll type in the left side as your first equation, sine squared x minus sine of x. You'll type in the right side as your second equation. Make sure your calculator is in degree mode, which means you need to change the window to go from 0 to 360. And then if you do that, you will see that the lines cross each other at 3 points. Bing, bop, boop. And you can check the bing, bop, boop with second, or find those values with second trace, right? And then option 5 has you find intersection points between 2 curves. But you type in the left side as one of your y equals lines, the right side of the equation as the other y equals lines. It'll graph both of them, and then you use the intersect tool to find all 3. For the homework, you can just use Desmos, and then you can just click on the points, which is really nice. But the TI-84s, you can't click on the points, which is not so nice. You just have to go through like this bunch of button presses. Yay? Yay. Okay? Again, there's a reason why we're taking 2 days for this lesson, and then we're going to review for 2 days. This is a hard bundle of lessons right here. Okay, so for the rest of 8.5 here, we're just going to do more examples, and then I don't know if you'll have time to work today, but ideally, if we can get through them quickly enough, you will. All right, let's do subpoint B in your notes then will be more examples. Okay, let me show you one more strategy you can use to solve these problems. Let's look at 2 sine of theta is equal to the cosine of theta, where 0 degrees is less than or equal to theta is less than 360 degrees. And we want to find out what values of theta will satisfy that equation. 2 sine of theta equals the cosine of theta. Okay, so if you follow along so far, you might notice that this one does not follow the same vein as the rest of our problems. It does not look like it is of quadratic form. Right there is no squared. Uh-oh. In which case, we run into that problem is how can we relate this into one trig function so I could solve it like a linear algebra problem. And here's what you should do. Let's go ahead and as our first step, divide both sides by the cosine of theta. If you divide both sides by the cosine of theta, what is sine divided by cosine? It's tangent. And what's cosine divided by cosine? It's 1. Isn't that cool? And now this is an equation I think everyone in here could solve. What would be your 2 steps to do it? Divide by 2 and then tan inverse. Does that make sense? So I don't know if we have to work through it. Do you want to work through it? No. This is one where if you see that they are not quadratic form, then your goal is to try to get it in terms of one trig function, and then hopefully it'll become like a linear algebra problem that you can solve. So try to get down or try to reduce to one trig function. And usually you will do that by multiplying or dividing. Trig fraction. How about function? Yay? Okay, let's look at another one that'll look deceptively similar to it, but actually is a lot harder. All right, same rules. Theta has to be between 0 and 360 degrees, and we want to find out what theta is. For 2 sine of theta equals the cosine of theta plus 1. Okay, here's your issue with this one. If you try dividing by cosine, what you will get is tangent 1, but then you're going to get 1 over cosine here, because that extra stupid plus 1 here. And 1 over cosine is what? Secant. And no. That's not in terms of one trig function now. You'll have a tangent and you'll have a secant. If we subtract the sign over, yes, this is what we want to do. Yes, you're on the right track. What we want to do is, well, we know sine and cosine relate to each other, and although I don't have sine squared, I wonder, can I solve this for just sine? Right? are just cosine. Let's do it for just sine. I think it works out easier if you do it for that. That's right. We can. Let's do it. All right, first thing to get sine by itself, right, is I'm going to subtract. So I'm going to get sine squared is going to be 1 minus cosine squared. And you're right, there's another problem again where there's a squared here but not a squared in our problem. How do I get rid of the squared? Square root. Yeah, that was a more dramatic pause than probably it warranted. Okay, I'm going to write this wrong, and then you tell me what's wrong about it. Yeah, that's wrong. It's got to have a plus or minus. Whenever you solve a quadratic equation, or solve to get rid of a squared, right? The only valid rule to get rid of that is plus or minus the square root. Okay, so now if we substitute that back in over here, what you would get is 2 plus or minus the square root of 1 minus cosine squared theta equals cosine theta plus 1. Yeah, so instead of sine of theta there, we write what we solved it for. Now, if you remember, okay, this is really relying on your algebra 2 skills. How do you solve equations that have radicals in them?
Quadratic function. How is it called? Like negative b squared.
That could definitely work. You have to be really careful with that, but that could work where, so for example, I know what you're saying. You're saying if you have an equation that looks like this.
Wait, I know. It's 1 plus cosine of delta.
That is of quadratic form.
Yeah, no, not that one.
But
Like the 2 parentheses.
yeah, but really, I think what will help is let's just get rid of the radical. How do we get rid of the squared root? And we square it. So we're going to square both sides. Square both sides. Over here, that's just going to be 4 times 1 minus cosine squared theta, and the plus or minus goes away, which is another real positive of squaring right now. And on the left side, what would you get? Well, this would be cosine of theta. Okay, my face is in the way. Cosine of theta plus 1 times the cosine of theta plus 1, which if you FOIL or double distribute is cosine squared plus 2 cosine plus 1. And then you're basically home free. You know what I mean by that? This is now definitely quadratic form with a single trig function, cosine. And I think if you get to here, you could take it the rest of the way. Do you need me to take it the rest of the way? For fun?
Yeah.
Sure. Okay, what do I do with the 4? Distribute. That'll be 4 minus 4 cosine squared theta. You know what the nice thing about pre-calculus is it's very therapeutic to write out all this stuff, isn't it? Don't you feel that? It's like it's like calligraphy, right? Or like raking sand, right? Just writing these symbols that, you know, if you handed it to somebody, there'd be a good chance they have no idea what you're talking about. Okay, what do I need this really to equal? Yeah, subtract all this stuff to get it to the other side. So I'm going to subtract 4, add 4 cosine squared, add 4 cosine squared, subtract 4. So you get 0 is equal to 5 cosine squareds plus 2 cosine thetas minus 3. Is that going to be factorable? We'd have to multiply to be negative 15 and add to be 2. It is factorable. You'd have to do the AC method. Do you remember how to do the AC method? You make the little chart. What's A times C? Negative 15. And then B goes down here. What are two numbers that multiply to be negative 15 but add to be 2? 5 and negative 3. So then this becomes 0 is equal to 5 cosine squared plus 5 cosine theta minus 3 cosine theta minus 3. Yay? Did you have to do a lot of that on the ACT on Tuesday? AC method? No? Usually it's nice because unless they tell you to factor, then you could just, if all they tell you to do on the ACT is solve, then you could do the quadratic formula. But if they tell you to factor it, there is a cheat, right? You do the quadratic formula and then you take your answers and make them into factors. It's pretty cool. You got a lot of stat stuff on it? That's lame. All right, what do these have in common? 5 cosine of theta, and that would leave me with cosine of theta plus 1. These have in common negative 3. That leaves me with cosine of theta plus 1. Which means my factors are 0 is equal to 5 cosine of theta minus 3 times cosine of theta plus 1. Yay? What if you couldn't factor it?
No, if it's not an exact answer.
Like 3/5 here? Yeah, you're right. Like this one is cosine of theta is going to end up equaling add 3, divide by 5, 3/5. And that is not on your unit circle. So this one you'll do the arc cosine and you'll get a decimal answer. Or at least not whole number. This one you'll get cosine of theta is -1, right? And then for both of those, you really could just grab your calculator for both of these. This will happen at 180 degrees. This will happen at whatever the inverse cosine of 3/5 is. That's going to give you the answer in quadrant 1. Right? And then you're going to have to ask yourself, in what other quadrant is cosine positive? Quadrant 4. Yeah, so if we do that, cosine inverse of 3/5 is, our first answer will be 53.130 degrees. That's in quadrant 1. The other quadrant where cosine is positive is quadrant 4, right? Because if you think cosine is x over r, where is x positive? To the right of the y-axis. So then you're right, yeah, 360 minus 53.130. Or, 306.870. And then when you go to solve your other factor here, that one you could probably just do in your head. The other factor is 180 degrees. That's where our x value on the unit circle is -1, is at 180 degrees. And then you might say, wow, I got lost, right about here and just started making some stuff up. And I'm not sure whether or not I got the right answers or not. But again, you could just type in y, my first equation, y equals that. Second equation in my TI-4, y equals that. Hit the graph, find where they intersect. You'll get all three answers. Yay? Okay, do we have time for one more? 7 minutes? All right, last melon. And again, we won't have to, we don't necessarily have to work this whole problem out. I just want to show you one more strategy. Or maybe I'll have you show me one more strategy. No, I'll show you. We'll stick with the red. That's fine. What are we on? Subpoint. Last example. Okay, so if we're following our trend so far, if we'll look at that, we'll say, oh no, this doesn't appear to be quadratic, which can be a plus, right? We might be able to do some linear algebra stuff to solve this. However, there's a problem. It's got two different trig functions in it, sine and tangent. You might think, all right, so I'm going to multiply or divide by something to get this all in terms of 1. But I'm going to tell you that's going to be pretty difficult to do because this is really sine squared over cosine equals sine over 1, right? And it's going to be pretty difficult to get those all in one. Or at least, I don't know if that's the easiest way to solve this problem. Here's what I'm going to recommend you do. If it's just 2, when there's a trig function on both sides that match. So these match. So here's the trick. Subtract by the right side to get them all on one side. And then if you look at that, the reason why I say this is great that they both match is because then I could just factor that out. And a strong hint that this is going to work is if you look at this original one and you divide both sides by sine, right, they'll cancel out. Now that's going to make you lose a root, which is why you're not really going to divide both sides by sine. But if you notice that you could divide to get rid of a trig function, that's a strong hint that if you subtract it to the other side and then factor it out, you'll be able to solve this relatively easily. So if we factor out, since they both have sine of x, you'll get that. And then the question becomes, when is sine equal to 0? And when is the tangent of x minus 3 equal to 0? So we separate it into two equations. Take the inverse. Sine is 0 when y is 0, which happens at 0 degrees and at 180 degrees. Oh, shoot. One of those is not a real answer back there. I was just thinking about that. We're going to go back to that problem in a second. I forgot the last step. For this one, we need tangent of x to equal 3. So then you inverse tan, and that one is going to be decimal. But you should get that that happens at, where's one? There it is. (71.565 degrees). And then you ask him what other quadrant is tangent positive. Well, tangent is positive in quadrant 1 and in quadrant 3. So my last answer would be 180 plus that, which is 251.565 degrees. Okay, I just jogged my memory when we were doing this. When I said if you divide here, you're going to lose a root because we won't find out when sine could be 0, which would make this true, right? If sine is 0, the left will be 0 and the right will be 0, and that's a valid solution. When we squared right here, we gained a root. So you have to go back and plug each of these answers in to this original equation. Type them all into your calculator because one of them is an extraneous solution. It's not real. And if I remember correctly, the only ones are 306.9. This one is an extraneous solution. If you plug that back into this original equation, it will not work. You'll get the 2 sine of 306.870 is negative 1.6. And the cosine of 306.870 plus 1 is positive 1.6. And when you squared it, it didn't care about the change in signs, right? Because the negative number squared is positive. So you have to go back and type. All right, that finishes 8.5. We'll review on Monday and Tuesday. Have a good day.